Okay, good morning, everyone. So I hope the stream somehow works out. So welcome to my talk at ContainerDays. So give me a sec to share my slide and then we keep it going. Here we go. Okay, so welcome to my talk, Hijack a Kubernetes cluster, a walkthrough. Before we talking about the brief agenda and so on, that just quick introduction of mine. So my name is Nico. I'm senior cloud DevOps consultant at Hijack. So Hijack is a company near Munich, so in Germany. I'm being a Microsoft MVP, doing some stuff for GitLab, being GitLab hero, and mainly focusing around container technologies, Kubernetes, and cloud native stuff in common. So before we do a deep dive into my talk, first of all, sorry. So I'm not in Hamburg today because I'm being on vacation in Italy at the moment. So basically, due to shifting the dates again for the conference and stuff like this, I'm not able to join in person. And I'm also not sure if audio and video and the stuff is working perfectly. So I moved to a co-working space here to deliver the talk. So I hope everything is doing like it should. So sorry for that one. Okay, so the talk today. So basically, it's a security talk around Kubernetes, container security, Kubernetes security, but it's not a really in-depth security talk. So the main reason for this talk is because I'm seeing on my day-to-day work that people are running Kubernetes cluster without any security. So not implementing security best practices or container best practices, Kubernetes best practices and stuff like this. Which leads you to have some common tech vendors and have an insecure cluster at all. So this talk is mainly about showing you what can happen if your cluster is open and not secured, and also talk a little bit about some best practices you should have in place. So if you are a deep dive security person, I guess this will not be the talk, the perfect talk for you. So it's really about implementing the basics, talking about the basics, and talking about what could happen if you don't secure your cluster. We will do this the whole talk basically slideless and just doing some demo, some hands-on stuff, and then I will show some talk about some of the details. So if you would like to do it on your own or to review some of the commands I used, you'll find all the whole talk on GitHub. So I included the link here. So it's just on my GitHub repository and Meisenzahl and then hijack minus Kubernetes. Okay, so one last slide before we start. And here also try to enable the laser. Here we go. So what we will do the next minutes. So basically we will be the attacker and we will try to attack an application and attack a Kubernetes cluster. So first of all, we will open a browser-based application. It's called Ping Me app. So basically, it's a just web application which allows us to put an IP address into an input field and then push a button, and then the application will ping this IP address and will disperse out the response. So it's basically just a simple application. But we will use this application to inject some code. And we are able to inject this because of some unsecure written code. And with this, we will be able to inject some scripts into our container. And from this container or pod in our cluster, we will then open up a reverse shell to an attacker machine. So the attacker machine is just basically a virtual machine, which is available in the internet, has a public IP so that we can connect to. And then we have an open shell into our container. And from there, we will try to talk to the Kubernetes API server. We will try to schedule some workload, some privileged workload, which then allows us to hijack our node and maybe get some more information from this node, and also hijack our cloud provider, or at least get access to the cloud resources and see if we can do something there. Yes, so from that, we'll deep dive into the demo. So this here, what you see now is our ping.me app, which is basically the app, the web app I was talking about. So if we put in here just an IP address, just as localhost in this example, and executing it, we will first get a response of our command itself, and then we're getting the output. And here we see our normal ping output. And as you see here, it really looks like the application is just really executing the ping command in Linux, in a bash or something else, and provides us the output. So looks like it's something to do with shell, with bash, or something else. So let's see if we can go back and see if we can inject something. So let's do again the IP address and then put in a semicolon, because we might think it is something related to a shell, and putting an echo behind. So just echo I was here, and see if we can execute this one. So once again, we get our command, and we also get the output from our ping here. Same again, but here at the end, you see, we also get our I was here. So it somehow looks like we are able to inject further code with a semicolon, which is pretty nice. So it looks like this is somehow not secure code. We are able to inject the second command, or maybe also a third command. So it's something we can use to somehow get access to the container, maybe. Okay, so let's go back. So because we now know we can inject something, we can skip the IP address completely, just using the semicolon, and then let's see if there's a bash available. So we're just looking if there's a bash available. Output is bin bash, so this container has a bash available, which is nice. So with this, we can maybe get some more details from the container. But let's go to my VS Code here and just do a quick sum up. So we'll make this a little bit smaller. Okay, so what we did, we checked it or we tried normal application with our IP address, we injected an echo with semicolon, and then we checked if there's a bash available. So we did not yet hijack or inject it into the container itself, but at least we found a spot where we can dig a bit deeper. So before we do this, let's talk about how we can prevent this attack. So basically 2 or 3 big points here. First of all, the issue we are now using to inject into a container is basically just a security issue when writing code. And the first option would be to use pair programming, review pull requests to just check, let someone check your written code to make sure that you might not have some security issues in it. So basically shift security left. On the other side, it's also recommended to really shift left security and enable code scanning, code analysis, static code analysis to find such kinds of issues in your code before merging them. So basically, you're running security checks, code checks in your pull request pipelines to make sure that you will find such kind of issues upfront. And basically, the issue we are now using, I will show you in the code later, is basically something every code scanning tool will detect and will alert you to fix it before it's in a running environment, before it's in a test environment, in a production environment, and so on. So shift left security. And then I'm building secure and small container images. So basically, this application is based on Golang. So we wouldn't need any shell or any Linux related stuff in our container image. So basically, it would be enough to run this application just with the Golang binary itself. So to give you some more details here and include some links. So there's a project called DistroLess, which allows you to run applications without a Linux distribution in the back to really remove all the unneeded stuff which you don't need to run your application, which you might need to debug or so. And wouldn't we have a bash available, we couldn't get further with the example here. Okay. So, but we did not yet inject into the container. So the next step we need to do is we first of all need to connect to our virtual machine, the tech host from our picture. So if I go back to my slide, so basically the attack machine here, and open a port. So I'm already logged in or SSH into the attack VM. So we'll now just copy paste the command here and doing a netcard and open a port 80. So you can use any port here, but I decided to use 80 because it's pretty common to let applications connect to maybe other services on 80 or 443, so HTTP or HTTPS, but we could also use an hypert here or something else. So now what we'll do is copy or use this command here in our ping application. So once again, we're starting with a semicolon because we don't want to ping, we just want to inject something. And we now, because we know we have bash available, and there are other options to do this also without bash, we executing a command saying, hey, I would like to run a bash. And in this bash, we would once again run a bash, but redirect all traffic to this IP address on port 80. So if I now hit go, basically the application is just loading and will be broken. But if you go back, we now see we are root at sample app, blah, blah, blah. So if we're now doing an ls, we're having a bash available in our container. And this done with a reverse shell. So basically the container connecting to our virtual machine and not the other way around, which might be closed due to firewall settings or so. So here we can just have a quick look in the main.go file because we now have here our Go binary. We have all of our code available, so we can just show you the code line which was causing this issue. And it's basically here the execution of command and telling, hey, we would like to have a shell, we would like to execute something, we would like to execute ping, and then putting any input afterwards. And basically this just plus input allows us to input anything and also inject with a semicolon further commands line. So this is basically the line which allowed us to inject to the container. And any SAS scanning tool would have prevent that one. Okay, so now we are in the container. So let's talk some seconds about why this was able and how we can prevent such kind of attack. Okay, so first, once again, build small and secure images. Once again, wouldn't we have available a bash, we wouldn't be able to open up a reverse shell so easily. So once again, small images. And then second one, very important, define and implement network policies in your Kubernetes cluster. So we have chosen a reverse shell because incoming ports are most of the time closed, but outgoing ports, so basically the application talking to the internet, is sometimes open. And we also have chosen port 80 because it is the port for HTTP. So it's even more likely to be open to the internet. So if you're implementing firewall rules outside the Kubernetes cluster and in the Kubernetes cluster network policies, you can decide which pod is allowed to talk to which application or to which service in the internet or also in the intranet. So please implement network policies and decide which workload should be able to talk to which endpoint. So with network policies, we won't be able to open a reverse shell at all. On the other hand, you can use open source tools like Falco or others, basically container runtime security tools, which allows you to detect untrusted workload in your container. So which now, what was now happened was that we opened basically a reverse shell in a bash. So we executed a second command in our container, executing the bash. And with Falco in place, we could have detected this and could either throw an alerting or also deny the second command or process to being started. So also Falco and other tools would have helped here a lot to prevent this attack. But for now, we have just accessed the Kubernetes, the container or the pod in the Kubernetes cluster, and nothing further. So let's see if we have some more options here. So let's try to see if we can talk to the Kubernetes API. So if our container or our service principal, which is basically the identity of a pod in a Kubernetes cluster, has access to talk to the API server. To do so, we have everything available in our Kubernetes in our pod. So first of all, we're getting the token for the service account, and this is stored in a folder or mounted in our pod. So basically, we can just do a cut and var run secrets Kubernetes IO service account token to expose our token to this environment variable. Same for the CA certificate. This is also available and mounted into the pod, so we can just expose it. And now we can use curl, which is also a tool which is available in our container, but we wouldn't need it at all. We can use curl to talk to our Kubernetes cluster. So if we're now doing a curl, we need to provide our certificate, which we can do here. We need to provide an header, an authorization barrel token with our exposed token here. And then we're saying, hey, we would like to do a get on HTTPS Kubernetes service host. This is also exposed automatically. And our Kubernetes service port, and then doing a /API here. So we now hit enter. We will get feedbacks on the Kubernetes API server. So we could either get a deny or we get some feedback. And here it looks like we're getting the version, we're getting some details. So it looks like we are somehow authenticated and somehow are able to talk to the API server. It doesn't mean we have much rights to do anything, but we have at least some rights to do something. So let's see if we get some details from workload in our namespace. Also, the namespace is mounted to the pod per default. So we can just use another cut and expose our namespace here. And doing a similar call command. All different is that we're extending our URL to /API v1/namespaces, our namespace, and see if we can get the pods here. So, and it looks like we are getting some feedback. So it looks like we see here a container pod named a sample app. It's ready. We see the image and so on. So basically, we are at the moment seeing our own container because it's the only container running in this namespace, but we're getting all the details of the container here. We're seeing the name, we're seeing the labels, and so on. So it looks like we have at least read access into our own namespace. So because of curl being a little bit complex, it's hard to see all the details, and we know we have internet access. So why not just download the latest kubectl command using curl, because we also have curl available, and move it to user bin to be able to use kubectl to see if we get some more details. And all the exposed information above, we can also use with kubectl now. So let's see if we can do a kubectl get pods. And here we go. We have our pod available. So let's see if we also get pods from a different namespace. Okay, here it says system service account default. So the default account and default namespace is not allowed. Okay, so let's see if we can read the nodes. Okay, we are also not allowed to see the nodes here. So let's check with kubectl whether we are allowed to create a namespace, to create a pod in our namespace. So basically the default namespace. See if we have write access instead of just read only. And we see we have the ability to also create a pod in our namespace, which we do just in a sec. So once again, what can we do to prevent this or to prevent the attack? First of all, why we were able to use this was because our service account had rights, so basically had role bindings in Kubernetes. It was able to read and write to the Kubernetes API. So this is not default. So default behavior would be an access denied, but I saw many Kubernetes clusters where some service account had role bindings due to just a snippet which got copy pasted into the Kubernetes cluster, or in third-party integration where you didn't have an install and the deployed also some role bindings that you did not choose your own service principal, but have choose the default one, which is default if you do not provide one. So basically there are many scenarios where you end up having a privileged default service account also without knowing it. And this is the best example here. So basically this application does not need any access to the Kubernetes API, but it has access, and we can now use it to get even deeper into the cluster and see even other things. So first of all, do not share service accounts between applications. Do not use the default account if not needed. If you have service accounts with higher access, make sure to be aware of them and only remove the role bindings when you remove the workloads, and do not just copy paste snippets and stuff like this without checking what they are doing, so that you do not lead up with having privileged service accounts somewhere. Then also really important, you can configure your pods to be to use a read-only file system. So we have now downloaded kubectl and have stored kubectl somewhere. Of course, we could do the same without kubectl, but it's way more easier if we have kubectl available here. So also use read-only file systems if it's possible for your application. If not, also use read-only file systems, and maybe use some mounts for the places where your applications need to store temporary data or stuff like this. Yeah, and then once again, since we already talked about, limit your egress access to the internet. Without that, we wouldn't be able to install kubectl. Use small container images again, and also detect untrusted processes in your container workload, because this one we would be also able to block and detect with, for example, Falcon. Okay, so we are now inside our container. We know that we are able to create a pod. So let's see if we can create one. So what we now will do, we will do a kubectl apply with this definition. Basically, what we are running here is an Ubuntu image. So let's try Ubuntu. We have nearly everything available which we might need. And we're also doing a mount. And what we will mount is our host path. So basically, we'll mount a directory from our Kubernetes node, and we will try to mount the run containerd. So to be able to talk to the containerd on our host. So for this, we will first of all need a host path volume. On the second hand, just a sec. And on the second hand, we also need we also will try to see if we can get a privileged container up and running, just to get some more access we could use later. So let's see if this works. So container got created. So we were able to use host path as a mount volume, which is not good. we were able to create a privileged pod, which is also not good. So now let's execute into this container, and we once again have kubectl available because we were able to install it, and just starting a bash in the container. So, and now we have a container running. In the container, we have a mounted container daemon from our underlying host, and from here we can see and start if you can see some more details. So first of all, let's install some more stuff into here. We need curl, and we can install jQuery to get a nice output. Once again, it's equals driven. Would have had been denied, we wouldn't be able to install just some things. So taking some time, and it's done. And we also need the ContainerD CLI to easier see what's running on the node itself. So it's also done. Okay, so now what we now can do is we can use the ContainerD CLI, provide so the ContainerD socket. In our case, it's mounted to mount. So it's mount ContainerD.sock. We're providing the namespace that we would like to see everything related to Kubernetes, and we would like to do a container list. So I'm now making it a little bit bigger. What we now are seeing is that we are now seeing all containers running on our local node, which we would not have seen in the Kubernetes context. So we are now connected to the ContainerD on the node, and we're seeing everything which is running here. So pretty nice. Okay, so let's see if we can get some further details. Well, first of all, let's talk if we how to prevent that one. So first of all, once again, do not run container root containers. You can implement policies and use tools like Opa Gatekeeper or Kibano, and then link both to deny to be able to run root containers, to deny to run privileged containers, to deny to use host paths to mount your local machine host paths. So this could have all be denied by policies, and from there we wouldn't be able to inject even further. So the next thing we could do, and I have to check the time, so we're a bit late already, is that we now could once again use our ContainerD runtime and basically grab for a specific container, and then use this container ID we're getting here, and use once again ContainerD CLI, provide the namespace, and do container info on this ID, and then basically query the specs and get some process information. So maybe just doing a quick one here, just picking any ID here, and then putting the jQuery at the end, and now we're getting all the environment variables from this particular container. So best practice in the cloud native world, in the container world, is to expose environment details, secrets, and stuff like this via environment variables. So, and now, for example, we would have an application which has a database connection string as an environment. We could now have used this connection string with all the credentials in it and try to connect to the database and extract data from there. or also delete the data there. Would have worked probably because we do not have, looks like we do not have any network policies in place. So we would also talk to the cloud provider, talk to the database, get the data, dump the data, upload it somewhere else, or stuff like this. So not really nice. So how to prevent this one? It's basically the same. Tech is also based on this container. So basically, once again, implement policies, deny such things like root container, like privileged container, deny host pass mounts and stuff like this, and all the other things you already talked about. So last but not least, we could also now use this state we are in to also talk to the cloud provider and talk to resources in your cloud account. Therefore, we're just mounting the whole disk from the machine, from the host, and see if we can get some more data. So what we'll do is we're doing this mount command here. Basically grabbing the first disk, first local disk, and mounting it to /temp. And now on the local machine, there's a directory where some cloud related stuff is stored. So there is a file where there is an ID from your cloud provider account, which basically the cloud provider used to authenticate different things. So in this case, this is running on Azure. It's running on the Azure Kubernetes service, but it's also working with all other cloud providers. And in this file, etcd Kubernetes Azure JSON, there's basically an ID in it. It's called on Azure that the managed identity, and with this identity, we can use it to talk to the Azure Resource Manager. And try to get some more details from Azure cloud resources. Maybe if we have access, create other cloud resources and stuff like this. So we're now just exposing this ID. And I can also show you that one here. Echo identity. So here we now have the ID of the underlying identity of the Kubernetes cluster and the virtual machine. And we now could also get a step further and try to get a token from this machine here. So this means we are now doing a curl and doing this curl against the so-called metadata service. Although this one is the Azure metadata service, but it's also available on the other cloud providers and can be used to retrieve some kind of information from the cloud. And we are saying here, hey, metadata service would like to get for our identity an OAuth 2 token. We are providing the client ID we have. We're defining some API version, some more specs, and so on. And then hitting the enter taster, and we now have a token available. And with this ID and with this token, we could now talk to our cloud provider and retrieve information from other cloud services we have access to, maybe also creating other cloud services. So with this both, and I can't show the token now because you could use it, we are able to really hijack the whole cloud world and schedule, I don't know, a virtual machine and mining some Bitcoins or something. So nothing related anymore with Kubernetes. We are also now outside of Kubernetes and really running on the Azure provider. Okay, so with this, we are pretty end of time. But let's see, I will stop share my screen. So let's see if we have any questions available in the platform. Oh, we have, so give me just a sec. Oh, shit. Oh, okay. Looks like there are some technical issues. Okay, so no questions here. Okay, so sorry for the issue. So it looks like the YouTube stream worked, but the talk is not available on the platform. So I will try to share the link again, and you also find it on the internet later. So sorry for that one. Okay, so have a nice day, and see you. Bye bye.